We have already seen like if Z1, Z2, Z3 are given in complex number and we have to apply the formula for theta, right? We know that, right? In anti-clockwise direction, we have to go. And in this anti-clockwise direction, this will be Z3 minus Z1 upon Z2 minus Z1 is equal to mod of Z3 minus Z1 upon mod of Z2 minus Z1 e to the power I. This is Pony theorem or rotation form. And based on this only, we'll get question from like geometrical question of complex number. It may be in your IUQM examination or RMO or INMO or IIT, anywhere, right? You'll get question from this portion only, right? Definitely, you'll get question from this portion, right? So we have already proved that like Z1 square plus Z2 square plus Z3 square is equal to Z1 Z2 plus Z2 Z3 plus Z3 Z1. If this is given, so the triangle must be equilateral, right? ABC must be equilateral, right? Equilateral triangle. We have already seen this in last lecture. I guess everyone is okay with this, right? Last हम लोगों ने यहीं पर खत्म किया था, right? Now, for revision purpose or just for starting purpose, I'm giving you the question. If Z1 and Z2 are given, Z1 is 3 plus 4i and Z2 is 5 plus 7i. If the triangle is equilateral, find Z3. If the triangle is an equilateral triangle, then find Z3. Then ABC equilateral. Then you have to find this. No?
So can you repeat the question?
If ABC is an equilateral triangle and Z1 is given as 3 plus 4i and Z2 is given as 5 plus 7i, we have to find Z3. That's it. A simple question. Done? Only you have to use the formula. If like what I'm saying now, Z3, you can also write this as 3 plus 4i. I'm not saying you have to use the geometry, right? Only with the algebra also, you can find this. Z1 is 3 plus 4i, Z2 is 5 plus 7i, plus Z2 is 5 plus 7i into Z3, plus Z1 is 3 plus 4i into Z3. That's a quadratic, and you know how to solve the quadratic. At Z3 you can find. Or by rotation formula also you can find. Very good, Patani, very good, beta. Two values you will get, right? It may be the rotation in the clockwise or it may be the anti-clockwise. So not only Z3 is coming on this, maybe Z3 will be here also, right? So one time you have to go with the positive angle and one time you have to go with the negative angle. So two values are possible in this. And from quadratic also, you'll get the two values. Okay, everyone? Right? I hope you all know in the coordinate system, if the triangle is given, whose vertex are the complex as Z1, Z2, and Z3. So the first formula is known as the centroid. The centroid is Z1 plus Z2 plus Z3 upon 3, right? And the second formula is for in center, that is A into Z1 plus B into Z2 plus C into Z3 upon A plus B plus C, where A, B, C are the length of the sides of a triangle. This is called the in center I, right?
So can you repeat the first?
First is the centroid. First is the centroid. The centroid means,
So that is equal to sign in between.
yes, centroid Z1, Z2, Z3, A, B, C. The median, concurrency of median is known as the centroid. This medians means this is the midpoint B, and we know that the centroid divide in the ratio, right? G divides AD in the ratio 2:1, and D is the point. So this is the midpoint. So the ratio formula, the proportion formula, Z2 plus Z3 by 2. And then applying 2:1. So section formula, I'm getting this as Z1 plus Z2 plus Z3 by. So this is centroid. The coordinate of centroid is represented as Z1 plus Z2 plus Z3 by 3 by the section formula, as we know, right? First. And the second, what I said, if this is the triangle given ABC, the angle bisector, internal angle bisector of A, internal angle bisector of B, that intersect at I. So we have to find I. So this BD is to DC. This is divided in the ratio C is to B. And AI is to ID divided in the ratio B plus C is to A, right? So if this is Z1, this is Z2, this is Z3, this will be B Z2 plus C Z3 upon B plus C, and then ratio proportion AI is to ID is B plus C is to A. So this I will be A Z1 plus B Z2 plus C Z3 upon A plus B plus C. Right? Now, based on these facts, right? Based on these facts, I'm giving you the question, right? A simple, very, personally, I believe this is a very good question, right? In any triangle ABC, the vertex are Z1, Z2, and Z3. Let Z be the point. Let Z be the point, right? Such that 1 by Z minus Z1 plus 1 by Z minus Z2 plus 1 by Z minus Z3 is equal to 0, right? 1 upon Z minus Z1 plus 1 upon Z minus Z2 plus 1 upon Z minus Z3 is equal to 0, right? Then prove that the complex Z must lies inside the triangle ABC. Then prove that this Z must lies inside the triangle A, B, and C. Question is clear, everyone? Question is clear? You have like what we have done, the sufficient formula is there for you. Only the basic things you have to use, but the planning is very important, right? So,
Sir, is this an equilateral triangle?
no, not at all. For any triangle, this is true. For any triangle, this is true. May I start or you want to try?
Sir, 1 minute, let us.
Okay. Done, everyone? मैं कुछ हिंट दूं? Let's see. Anyone? Anyone on this? See. It's a beautiful arrangement of numbers, but in this question only you can understand the use of complex number, right? How you can use this. I can just taking the conjugate of this. Is this okay, everyone? Now, multiplying with z minus z1. So the denominator will be z minus z1 ka mod square plus z minus z2, right? Upon z minus z2, the mod square plus z minus z3, z minus z3 mod square is equal to 0. Now, let's suppose 1 upon z minus z1 ka mod is equal to a, 1 upon z minus z1 is in the mod square is equal to b, and 1 upon z minus z3 mod square is equal to c. So this is a z minus z1 plus b z minus z2 plus c z minus z3 is equal to 0. Or from this, I can say z is equal to a z1 plus b z2 plus c z3 upon a plus b plus c. What is the meaning of this?
In center.
In look like as in center, we can't say this is in
ABC अलग है.
these ABC are not same. Look like as in center, and in center always lies inside the triangle. But
So
this
that means it's inside.
this look like as in center, but this is not in center. But what I am saying, yes, I have proved. मेरे को तो जो करना था मैंने कर लिया, and now I can like freely I can say कि okay, I know 100% the point is lying inside the triangle. How? From this result, I'm saying कि no, I know this is now lying inside the triangle. How this is possible? Anyway. और कुछ हिंट दो. Section formula. What does this section formula says? If I'm saying I have to divide this pencil into 2:1, this is the length of the pencil. I have to divide in the ratio 2:1. So this is 2, this is 1. So this is 2:1. I'm saying I have to divide this into 100:1. So here I'll get the point. Right. I'm saying I have to divide this in the ratio 1000:1. The point will be inside this pencil or outside this pencil?
Inside.
Everyone is agree with this. Now, inside means if you'll see these A, B, C, right? A, B, C, all are positive, right? These are
Yes, sir.
positive. So the division will be always positive division. So can I say, right? Let's divide this as something like this is ABC, right? These ABC are the positive numbers. Can I say this? This will divide BC in some ratio C is to B. Can I say this? Then 100%, if B and C are positive, I'll get the point here. Agree? Now, Z is not in center in this case. Z is look like as in center, but Z is not in center, right? We are saying ki if A and B and C are positive, the positive ratio of any division that will give you the answer in between that segment. Like, can you see, you all can see my this pencil now, just in video, right? So what I'm saying, ki, if this ratio is A unit, right, I have to divide this in the ratio 5:2. So in any time, the point will be inside this 5:2. 1000:1, right? Anytime the point will be here only. Right. So every time when I'm going for the positive division, the point is must lie on this line. Right. So if I'm saying ki BC is divided in the ratio C is to B, so the point will be here only. And what is that point? That point will be BZ2 plus CZ3 upon B plus C. Now, again, I'm saying if I'll join this A to the point D, right? And I'm taking this as B plus C is one of the number and A is one of the number. So this divide in the ratio B plus C is to A. So this point will be this only. And this, if A, B, C are positive numbers, so this point will always lies where?
Inside the triangle.
Fine. Is this okay, everyone? A very simple question. Use of only the very simple thing, but you can see the effectiveness of this complex number. We can't prove this thing with your coordinate system, right? We are not able to prove this, right? We can't reach like in this conclusion with any coordinate system. Is this okay? Okay. So the next one. If I'm saying mod Z is equal to 0, right? So mod Z is equal to 0, and we are forming a triangle ABC on this. Means this is the circle whose center is 0, and ABC is the triangle on this. Anyway, and the center is origin, right? So let this is Z1, let this is Z2, let this is Z3, right? One thing in any triangle, you know the Euler line. What is this Euler line? Anyone?
So the line that connects the circumcenter and orthocenter, and centroid and 9-point center also lie on it.
Okay. So HGO, right? What is this HGO? When I'll drop the perpendicular, this is called the orthocenter, concurrency of altitude, right? Second is the centroid, the concurrency of medians. Third is O, and this is G. This divide in the ratio 2:2. How this is going to be, right? See, I'll start with this. The triangle AHG. This triangle, and the second triangle ODG. Can you see this? This angle opposite to this one, right? And this is 90 degree. This is again 90 degrees. So these two angles are same, right? So obviously the third angle will be always same, right? The third angle, this one and this one, right? So both the triangle are the similar one, and we know that this divide in the ratio 2:1, centroid वाली जो line होती है. So this again divide in the ratio 2:1, the HGO. Very important result. This divide in the ratio 2:2, right? And और भी इसमें properties आएंगी, but later on, right?
9-point circle is का midpoint होगा.
Very good. Right? Divide in the ratio 2:2. Now, so yes, note down please, note down please. Then I'll use this on the triangle. This is very important. Lot many times you have to use this. So, but simple thing. Okay, okay, everyone. Done. Done. See. So from this I can say, right, in this triangle, right, circumcenter is the origin, right? What is the centroid of this triangle? Right? So can I say the orthocenter will be always Z1 plus Z2 plus Z3? Okay. Now, comfortable everyone? Done everyone? Right? So this is your, right, like how to use this now. It's coming into that. How to use this, right? So let's suppose I'm giving you a question. Mod Z is equal to 0 is a complex number, and A Z1, B Z2, and C Z3. Angle bisector through A intersect the circle again at Z5. Find Z5 in terms of Z1, Z2, Z3. Question is clear? Angle bisector through A intersect the circle again at Z1, Z2, Z3. Find this.
So is the circumcenter at 0?
क्या क्रिसिल?
So इसको circumcenter 0 पे है.
हाँ, mod z is equal to 0. हाँ, डिस्क mod z is equal to r.
So just 1 minute.
Sir, H stands for orthocenter, right?
क्या है, एक बार फिर से?
Sir, H is the orthocenter, right?
हाँ.
And O?
Circumcenter.
Okay, sir.
G is the centroid.
Should I send it?
Send the solution. एक बार solution भेजो मेरे को. सार कुछ उसमें उपाय करके कुछ you can do something. See how to use the geometry in this, and like how we will get this right approach on this. See, This is radius r, radius r, right? This is a circle. We have to form a triangle. Right? And this is a triangle. Angle bisector through A. Intersect the curve again at E. We have to find the point E, right? In terms of ABC. That this is the center. That is the origin. Mod Z is equal to some R is the radius of this circle, right? Is this okay, everyone?
Sir, E is the midpoint of BC.
Is
Arc
the
BC.
arc BC. You can see, right? Is this okay, everyone?
So I reflected O about BC to get E.
See, I'm giving you a very simple formation on this. Can I join this? Something like this. This angle is A by 2. So what about this angle?
A.
A, right? If this is Z1, this is Z2, this is Z3. By rotation, we know that this Z3 with respect to origin, this is radius R, this is radius R. So this will be Z3 minus 0 by Z2 minus 0 is equal to both the mods are equal e to the power IA. Means Z3 by Z2 is equal to e to the power IA. That's it. Similarly, this angle is again A. Can I say this Z3 by Z5 is equal to e to the power IA? This is Z5. This is Z5 by Z, Z5 by Z, right? This is Z5, right? Is this okay, everyone? The reflection you're saying, I'm saying like the rotation, right? So from both the rotations are equal, so I can say Z5 square is equal to Z2, Z3. Both are equal. Or you can say the similar triangle, right? So Z5 is equal to plus or minus under root of Z2, Z3. Is this okay? Getting this? Hmm?
Yes.
So दोनों expression same है क्या?
Huh?
So reflection वाला ये वाला same है.
Not exactly reflection is the same, but uh, like we have to manipulate this algebraically, right? So maybe I'll get something. So I have to work on that. The reflection. Check this out. Is this okay? Okay, everyone? बहुत सारे different results होते हैं, right? You have to just work on that, right? The second, okay, everyone, go for the second one. Go for the second one. What is that? If I'm giving you in the same figure, same, everything is same, right? This is the circle. Z1, Z2, Z3. Right. Try to use the rotation formula and geometry both. Altitude through A intersect at Z4. Find Z4 and reflection of Z4 with respect to line BC. Find Z4, find Z4 and Z4 reflection of Z4 with respect to BC for the triangle mod Z is equal to R. Take your time. The
I've
again
given the second answer.
second how okay.
सर ये perpendicular है क्या Z1 या bisect?
Yes, beta. Altitude है ना, altitude is always perpendicular.
Alternated. अच्छा, okay sir.
Sanjana, this we have done. The rotation we have applied twice for the triangle OBE and OEC. Right? We have applied a rotation formula for OBE and secondly we have applied for OEC. Right? Then and equated both the e to the power IA, so we are getting this. Huh? And now I have given a question. In mod Z is equal to R in a triangle ABC, AD is the altitude through A that intersect the circle again at D, that Z4. We have to find Z4 in terms of Z1, Z2, Z3 and a reflection of Z4 with respect to the line BC. Only two things, right? Again, a very good question and very good concept will come, right? So patiently first try, then we'll discuss. Okay. Four minutes you have. Take your time.
So we have to find a Z4 only using rotations.
You can otherwise also, not necessarily through rotation only, right? Different formulas are also
So
there.
can I use reflection formula?
Why not? Why not? You can go other way around also, right? But in the simplest form, we have to just go for that, right? That I'll give you the formula for that, right? Not necessarily always we have to go with the rotation, right? Reflection is very good property that we can apply on that.
So can we assume that all the points lie on the unit circle?
Yes, we say.
So can we assume all the points lie on the unit circle?
Like the answer will be in the form of Z1, Z2, Z3.
So the calculation would be easier for unit circle.
Units are, it's okay. Either you can take R or radius 1. No problem. No problem.
Instead of taking unit circle.
Yeah.
So let's send for unit circle.
Working, send me the working. See, not exactly, but let's try. May I try? May I try, everyone?
So 1 minute.
Curves,
Yes, sir.
done, reserve, क्षमा,
यस सर.
done. कुछ लगा बेटा?
नहीं सर, लगा ही रहा हूँ.
ये होने वाला क्वेश्चन है, होना चाहिए था. See everyone, see.
So 1 minute.
Okay. Obtuse, लगा कुछ क्या बेटा?
सर ट्राई तो किया, लग रहा है लगेगा बट नहीं लगा सर.
क्या क्या लगाया बताओ?
सर वही एंगल वाला जो फॉर्मूला था ई पावर आई थीटा, उससे ट्राई किया. देख के लगा कि हर चीज के लिए ट्राई करेंगे और इक्वेट करने की कोशिश करेंगे तो शायद आ जाए, बट कुछ आ नहीं रहा इसमें.
This is 90 degree, right? This is 90, right? And this is angle B. So what is this angle?
90 minus b.
90 minus, right? So if this is 90 minus B, what is this angle?
180 minus 2b.
Very good. So pi minus 2b, right? So I can use the rotation on this, right? Z4 minus 0 upon Z2 minus 0, because this is 0, is equal to, both are radius, r upon r, e to the power I, pi minus 2. So what I'm getting, Z4 by Z2 is equal to e to the power I pi into e to the power 2ib with minus sign. What is the value of e to the power I pi? Minus 1. Right? E to the power 2ib. Right? Is this okay, everyone? क्या यहाँ तक सही है? Note it down till this ना, फिर मैं आता हूँ आगे. अरे बहुत सारे वेरिएशन है इसमें, right? And only you have to use the little bit geometry, little bit rotation, right? You'll get the right. ऐसे ऐसे पॉइंट्स मिल जाते हैं जो लगता है कि लाइक हाउ टू फाइंड दोस पॉइंट. Okay, Z4 by Z2 is equal to -1 into e to the power -2IB, right? Now see, एक और यहां तक नोट कर लिया सबने? डन एवरीवन?
1 second, sir. Yes, sir. Thank you, sir.
See, this angle is B, right? This angle is B. If I'll join this to C and this A is joining to this. So if this angle is B, what is this angle? What is this angle?
2B.
Right? 2B. So if I'm taking rotation on this, so what I'm getting from this? Reaching to Z1 minus 0 upon Z3 minus 0 is equal to e to the power I to B. Is this okay? Both are ready, sir? Means I can put the value of Z4 by Z2 is equals to Z3 by Z1 or Z4 is equals to Z2 Z3 by Z1 with minus. So only this you are getting. See, Z4 is equal to minus of Z2 Z3 by Z1 with minus. First result. Right? Okay. And the second question was, क्या था second question? What was the second one? We have to find reflection of Z4 with respect to the line BC.
A plus B, and then Z1 plus Z2 plus Z3.
What is that? What is that?
Ortho center.
Very good. Ortho center. सब लोग try करके prove करो इस बात को तो. It reflection of D with respect to BC is ortho center. Try to prove this. एक बार फिर से सुन लो. Right, what I'm saying. Reflection of point D with respect to line BC is always the ortho center of the triangle ABC. Try to prove this. Everyone, try to prove this. Important result and very simple one. Right, please.
So could you repeat the question?
Reflection of point D with respect to
Point C.
the base BC is the ortho center of the triangle ABC. Yes. And if you have proof, just send me in chat. But really now, at least 2-3 times you have to go for this. Right, then only you'll be able to understand exactly what you are doing. And these are not simple things, right? You have to apply again and again and again. Then only you will get exactly what you are getting, right?
So can we continue?
Done. Done.
Yes, sir.
I've sent you the question of a complex number, na? Everyone, right? Just go through that, right? These are the simple questions what I have sent you. Just go through that, right?
और जो आपने 5 क्वेश्चन भेजा था वो वाले
हाँ हाँ
वो जो
तो
5
कर लिया होगा
क्वेश्चन
आप लोगों ने ना
या सर आई हैव ऑलरेडी डन इट
हाँ तो
इजी
now
था वो
just right now I have sent you few more questions. Yes. So who is going to prove this and how you are going to prove this?
So can I?
Please, just a minute. Just a minute. I have to make. Yes, please. Very simple proof. Yes. Yes. Who is going to? Listen.
So we can assume that D lies on the circle, right?
Mm-hmm.
And then H is the reflection of D. So we can connect BD and DC.
BD and DC. Just a minute. Just a minute. The construction I'll do with dotted line. BD and DC. Then
BAD equals 90 minus B.
angle I have to choose. Just a minute. Yes. Which angle you are taking?
BAD.
BAD. This angle is
90 minus B.
already we have find that 90 minus B.
So BCD will be 90 minus B, cyclic quadrilateral.
CD will be 90 minus B, right? Same segment.
So can you extend CH to meet AB?
Huh?
So can you extend CH to meet AB?
P
H to meet AB. So CH.
okay. CH you want to meet right there.
It is perpendicular to AB. So HCB is 90 minus B.
Okay.
So HD is perpendicular to BC.
Hmm.
So HCD is an isosceles triangle.
Very good.
So H is the reflection of B.
So both are equal. Right. Right. This okay? Okay, everyone. See. We can see this. One of the triangle is this one, right? This segment BD is, right, forming two triangles. याद है ना circles के लिए this angle and this angle will be same.
Instead angle theorem.
Same segment, right? Similarly, you can say this angle, this for this chord, right? You have one of this angle and other is this angle. Right, both will be same, right? And from this is 90 degree and just you have to take this angle, right? For this we have to drop the perpendicular. This is B, so this is 90 minus B, this is again 90 minus B, both are same. That's enough, right? Like both are isosceles. So isosceles triangle to HDC, isosceles triangle, and the angle bisector is same, 90 degree given here, so obviously perpendicular bisectors. Taken. So, and you have to remember this, right? This is the reflection of the point. Now, बहुत बार used, right? Okay. So I have sent you the question on this, right? And next, the complex number may just you all have to go with the revision of this. क्योंकि इसके बाद वाले पोर्शन जो है ना, थोड़े से हम लोग चलेंगे यूनिटी एंड पॉलीगन की तरफ, राइट, एंड ट्रायंगल्स एंड जो क्वाड्रिलेटरल्स एंड पॉलीगन्स पे जाएंगे तो द लाइक इंटायर सिनेरियो विल बी डिफरेंट, बट जहां तक अभी हुए हैं वहां तक के लिए यू हैव टू सॉल्व द क्वेश्चंस, राइट। तो आई हैव सेंड यू द क्वेश्चंस, मैं नंबर भी अभी लिख दूंगा उसमें, व्हाट क्वेश्चन यू हैव टू डू, राइट। वो क्वेश्चंस मैं लिख दे रहा हूँ, नंबर्स, ओनली दोज क्वेश्चन यू हैव टू अटेम्प्ट। I'm not saying each and every question you have to do, but only those questions you have to attempt. Okay? Okay, everyone?
Yes, sir.
Chalo, take care, right? And
Thank you, sir.
victory wali bhej. Okay? Thank you.
Thank you, sir.